right, we're starting 8.3. This is common logs. You need a calculator if you're watching this video. I'm going to show you how to run the calculator feature. Shush. Okay, go down to this box right here. We're talking about common logs. Here's what a common log is, okay? You have a button on your calculator that just says LOG, okay? And previously, we've been talking about logs, but we always have to have a base, like a base number down here for the log. But what if it doesn't?
Then it's 10.
Then it's base 10 because our number system thinks in units of base 10, right? Okay, so if it doesn't have a number, if it doesn't have a subscript, we think of it in terms of 10. That is a common log. A common log is a log with a base of 10. That's it. Not log base 2, not log base 7, base 10. That's it. Common logs, these are ones that you are allowed to put into your calculator. Now, the nice thing is any log can be converted to a base 10. So let's say I'm evaluating log base 2 of 9, right? Here's how you convert. I'm going to show you the first thing, and then we get to skip the example at the end when they show you how to do this. Okay, log base 2 of 9. Let's say I want to type that into my calculator. Ready? You do log base 10 of 9, because 9 is upstairs, over log base 10 of 2, because 2 is downstairs.
Okay.
And that's all you do. And it will give you the stuff. Okay? So, log base 2 of 9, if you want to convert it into something that you are allowed to plug into your calculator, all you do is log of 9 divided by log of 2.
It's
and
3.169925001.
1699. They'll usually have you go 4 decimal places.
That's
Okay?
pretty close to pi.
I'm sure.
3.141529.
Okay, now, what this means is, so this is how you convert. You do a fraction. Shh. This is what this means. If I take 2 to the little bit over 3 power, it gives me 9, right? What is 2 to the 3rd power?
Okay, wait.
2 to the 3rd?
What is 2 to the 3rd power?
8. It's
8. So 2 to the whatever power should give me 9. It's going to be a little bit bigger than 3, right? So that's how I convert it to a base of 10 so that I can plug it in. All right, moving on. What?
It doesn't work.
It doesn't work.
It works. I just did it.
Mine works.
Okay, now here's the problem. When you're typing it in, you have to be very careful. If it opens up a parenthesis, you have to close that parenthesis before you say divided by log base 10 of 2. Open, close parenthesis, okay? Otherwise, it will put it all underneath of one thing. Okay? All right, Trevin, here's... No, give it back to him. Trevin, here's what you type in. Ready? Type in 9 log divided by 2 log. Enter. Okay, you have to type it in backwards. Yes, sir.
What about if it's not log 10?
What do you have the?
Then you can. That's how you convert it to base 10. We'll get to that. There's other things that you can do.
What
Yes.
if you have the fancy calculator that does it for you?
Then you can change it to the base, like put the little number in the corner. That's fine. Yeah, I get it. Yeah. Okay. All right. Let's do some actual stuff here. Ready? Woo. Okay. Go to this box. Shh. No more questions. Go to this box. I'll answer questions here in a minute. Go to this box. Everybody look, go to this box. You tell them to get calculators out and they go crazy. I don't care. Put your hand down.
No.
Okay, go to this box. Shh. Okay, great. Go to this box. Log of 1 equals 0. The base of this log is 10. If I convert this is in log land. If I convert this to exponential, what's the base going to be? 10 to the
It's divided by 9.
0 equals 1. Is that true?
Yep.
Check. This is a base of 10. This guy says 10 to the
It's divided by 0.
first power equals 10, right? The first number stays in the same spot. The second two numbers switch. Okay, this one is a base of 10. This one says 10 to the
200.
second power equals
100.
100, right? First number stays in the same spot. Second two numbers switch. Okay? This guy says 10 to the
I bet that's about M.
m power equals
M.
10 to the m power, right? 10 to the m equals 10 to the m. Right?
Okay.
That's what it means.
Me no like
Okay?
you. Me
Oh, man. Okay. Now, let's move on down below. Example 1. Use the calculator to evaluate log of 8. Type in your calculator, log 8. The answer is, this guy, they want it to round to the nearest 10,000th. How many decimal places is 10,000th? 4 decimals. 1, 2, 3, 4. So, right here is it going to stay a 0 or is it going to become a 1? 0.9031. That is the answer to log base 10 of 8. Yeah? Good? All right, moving on. Example 2. Example 2. Let's skip example 2. Let's go to example 3. All right, go to example 3 real quick.
Brady, you're gonna get beat if you keep screwing with me, swear to God.
Beat him.
Okay, off to the side over here. Do this real quick. Go 2 to the x power equals 4 to the x minus 2. Let's do that. Okay, write that down. 2 to the x power equals 4 to the x minus 2. These are problems that we've seen before that we know kind of maybe how to solve.
Are we about to find an easier way to do it?
Oh, you
No.
didn't tell me the 4 was.
I
Okay,
remember how to
shh,
do
shh,
this.
shh. No, just wait. Nope, just wait. Write this down off to the side. Okay? In the past, we look at these two bases. We look at 2 and we look at 4 and we say, can we make them the same base?
I bet so.
Yes. 2 to the x, you can't do anything with that. But this 4 is like 2 squared, yeah? And then I have x minus 2. 4 gets replaced with 2 squared, all right? Now, this is 2 to the x equals. This 2 can get distributed, yeah? So 2 to the 2x minus 4. Okay, then what? The 2's are gone, so I have x equals 2x minus 4. Then what?
X equals
No,
4.
add the 4 over, subtract the x.
X equals
Sure, add the 4 and subtract the x. Okay? And when you do that, you get x equals 4. Yeah? Okay? We made them the same base. Example 3. We have a problem. Okay. Quit throwing crap. Give me that to me.
He hit me.
I don't care.
problem.
Example 3. We have a problem. What about 11 and 101?
Why'd they make it log?
I bet it's not.
11
equals 9.
11 squared is 121.
It's
That's not going to work.
0.8.
Okay? It's not going to work. So, what the heck do we do?
You plug it in,
All right, what we can do is okay, guys, you have got to listen. I am tired of talking over you and getting you to quit screwing around. Just listen. I have things I want to do, and I will be done in like 15 minutes if you just shut up and listen. Do it. 11 and 101, we cannot make those the same base like we did with 2 and 4, right? So, what we do is something that we can use a calculator for, and what we do is we insert a log in front of both sides. So I log and I log, okay? Because we did it to both sides, it's legal, right? I put a log in front of both sides. Now, we had a little fancy rule that says that, oh, by the way, what's the base of the log if we put him in front? Like what goes here? 10, and 10 is here. Okay, now, we had a fancy little rule that says that this x that's an exponent, he can go to the front. So this x came from up here down, traveling to the front, and there he has, like he's down in front. This is x times log 11, right? X times log 11 equals log of 101. Okay, now, if I want to get this x by itself, how do I get rid of the log 11? I'm going to divide by log 11 and divide by log 11. So I have log of 101 divided by log 11. That's a base 10. I can put it in my calculator. So what I want you to do is type this in, practice typing it in. Log of 101, if you open parentheses, you've got to close your parenthesis before you divide by that. And he is
1.9247.
9247 to 4 decimal places. Done? Okay, so when you cannot do this option, when you cannot create them to be the same base, you have to log in front of both sides and then do the algebra to solve. Yeah? That's not that bad, right? 1.9247. Anybody have problems getting to that point? Yes? Did everybody get it in their calculator? 1.9247. Beautiful. Beautiful. Are we still going?
I got the first 3.
Okay, let's do this one. Oh, this is going to be icky. Okay, we'll be all right, though. We'll be all right.
Whoa.
Okay, I'm going to solve him over here. I'm going to solve him over here. Write this down. 6 to the 2y minus 5 is less than 5 to the 3y. This is the next problem, but I don't like their work, so I'm going to solve it over here.
Just put -1.
Okay, there he is. What?
Put negative.
No. It's going to be a decimal, kiddo. All right. What are my two bases that I have? Shh. 6 and 5. Can you get those to be the same number? No. So we put log in front of both sides. Okay? Then what do I do once I put the log in front of both?
Put the
Move the-
exponents in
the
front
stuff
of
to
log.
Exponents come down in front. So this is 2y minus 5. That whole chunk times log 6 is less than 3y times log of 5. Yeah? Do you see how that works?
No.
Uh-oh.
Okay. Now what would you like to do?
Nothing.
Divide.
What?
Okay.
You can do a couple different things.
Could you move the 3y over?
Well, now why?
No.
Move the 3y
we know.
over.
Oh my god, you can't.
Okay, here's the deal. Log 6 is going to be a decimal, true?
Yeah.
Log 5 is going to be a decimal, true?
Yeah.
Let's just divide by log 6 and take log 5 and divide by log 6. That way all the decimals are on one side. Can we do that?
Yeah.
Okay, so I've got 2y minus 5 is less than, hold on, 3y times whatever that big ugly decimal number is. What's log 5 divided by log 6? What is that?
8982.
Question.
Okay, hold on. Shh, just wait. Hold your question for the end. Okay, so we've got our decimal over here on this side. Now what? Now what should we do? Can we multiply these two together? 3 times that 0.98982? 2y minus 5 is less than. What's 3 times that stuff? What is that? 2.6 something.
2.6947.
How did you do
Why?
part of that in your head?
Because it's 0.9 times 3, which is 27. Right? But not quite 27 because it's not 0.9.
Subtract 2y over.
Subtract 2y over. I like that idea. Subtract 2y. Negative 5 less than 0.6947y. Okay, if we subtract the 2. And then
Divide by point.
divide by the 0.6947.
And that would
Divide by
equal
0.6947.
Y equals approximately.
So y is greater than
9 point.
7.197.
7 point.
Negative 7.1973.
There you go.
Wacko.
Okay.
Oh,
So the key is that's as ugly as it's gonna get. I hope I don't give you anything that ugly.
7.4.
7-4. Perfect. Okay. That's as ugly as it's gonna get. Those are the hardest problems that you're gonna get. Okay. But the key is 6 and 5 were my two bases. I cannot make those be the same number like I could with 2 and 4. So I put a log in front of both, and then the exponents come down, and then I just do the algebra from there. Right? Okay? All right, I already showed you how to do this one. Log base 2 of 11. If I want to make those into base 10 so that my calculator can do it. Right now it's base 2. I want to make it into a base 10. Log base 10 of
11.
the bigger number. Not necessarily the bigger number, the up number over log base 10 of the basement number. So log base 10 of 11 over log base 10 of 2. Close your parentheses if you need to. What is that? Oh, wait. Let's take a guesstimate. Hold on. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. Okay, I'm guesstimating. 2 to the what power gives me 11? It's got to be some number in between 3 and 4. You see that? Because 11 is going to be a number between 8 and 16.
3.4594316169.
There you go. We're guesstimating. Between 3 and 4. 3.4594. Because you're seeing what exponent of 2 will give you 11, yeah? 11 lives between 8 and 16, so it's got to be a number between 3 and 4. Got it? But you are just log of the up number divided by log of the basement number. That's all you do to convert. Log is like an operation, like sine, cosine, and tangent. You're taking it of something.
Oh, okay.
Log is the opposite of doing an exponential function.
Ah.
So it undoes the exponential function. All right, go to, homework.
Yay!
Hey, there you go. Do 2 and 4 and 6. You can do them right now. 10 thousandths means how many decimal places? 4 decimals. Okay, 4 decimals. I'll let you skip 8. But do 10 and
Wait, 2, 4,
You can do 12 and 14. Those ones aren't that bad.
2, 4, 6, 10, 12, 14.
2, 4, 6, 10, 12, 14, and
That's it.
If you do it
22, 24, 26. 22, 24, 26. Okay, just real quick on number 22. It says express it in terms of a common log. If you just write down the answer, it's wrong. You have to write out the whole log base 10 of which number goes on top?
Do we really have to?
Whoa.
Yes, you do have to write it down.
200.
No, like,
200 over log base 10 of 12, and then write the answer down. If you don't, it's wrong.
hold on.
This is expressing it in terms of a common log, then finding the answer. You have to do both.
Do you
Yes.
actually have to write 10 though, or?
No, you don't.
That's
Good
not-
question. Good question. Yes. You could put log of 200 over log of 12. That's fine. Yes, I agree. That is fine. Okay, those. I need to write that down up here. 2, 4, 6. Somebody give me those. 2, 4, 6,
Wait,
10, 12, 14.
there was none in the bottom chunk?
Nope. And 22, 24, 26. Okay, there you go. Page 421. There you go. Those problems. Some of them are calculators. Some of them are really fast. Okay? The first 3 and the last 3 are really fast. The middle 3 are the ones that are going to take a little bit. Okay? But do the best you can.